Imagine a moon so violent, so electrically charged, that it doesn't just orbit a planet, it actually powers it. We aren't talking about a peaceful satellite hanging in the dark. We are talking about Io, a hellish, volcanic world that acts like a giant, chaotic electric battery. For decades, our old models of planetary physics suggested this kind of interaction shouldn't be possible. Yet, here it is, short-circuiting Jupiter's massive magnetic field. Today, we are diving into the impossible magnetic fields of Io to see how this moon is rewriting the rulebook of space science. Welcome to SciNova, where we explore the weirdest corners of the cosmos. If you thought Earth's volcanoes were intense, you haven't seen anything yet. Io is the most volcanically active body in our entire solar system. But its real secret isn't just the lava, it's the electricity. As NASA's Juno spacecraft performed its recent flybys in late 2023 and early 2024, it captured data that left scientists scrambling to update their textbooks. We're looking at a moon that is fundamentally linked to its parent planet in a way that defies simple orbital mechanics. To understand the chaos, we first have to look at the sheer scale of the destruction. Io is constantly spewing massive amounts of material into space through its relentless volcanic eruptions. This isn't just ash and rock, it's a constant stream of sulfur dioxide, or SO2. As these gases escape Io's weak gravity, they become ionized, turning into a swirling, glowing ring of charged particles known as the Io plasma torus. This torus isn't just a pretty ring, it's a massive reservoir of energy that sits right in the middle of Jupiter's magnetic domain. Now, let's get technical for a moment, because this is where the impossible part comes in. This plasma torus isn't just made of random gas, it's a complex soup of ions, specifically S+, S++, O+, and O++. These are sulfur and oxygen ions that have been stripped of their electrons. Because these particles are charged, they are completely at the mercy of Jupiter's gargantuan magnetic field. This creates a massive electrodynamical coupling, a fancy way of saying that the moon and the planet are now part of one giant interconnected electrical circuit. Think of it like this. Jupiter is a massive generator, and Io is a giant, messy resistor dropped right into the middle of the wires. As Io moves through Jupiter's magnetic field lines, it creates a massive electrical current. This current flows along the magnetic field lines, connecting the moon directly to the planet. This is what we call the Io-Jupiter system, a unique case of moon-planet interaction that is unlike anything else we've ever observed in our solar system. It is a literal bridge of electricity spanning millions of miles. But why did our old models fail? In the past, we thought of moons as passive objects, just rocks rolling along in a gravitational well. We didn't account for the sheer volume of mass Io supplies to Jupiter's magnetosphere. Through its volcanic activity, Io acts as a significant mass source, constantly injecting new material into the system. This constant influx of matter means the magnetic environment is never in equilibrium. It's always being pushed, pulled, and shocked by new particles. It's a system in a state of permanent, violent flux. The Juno spacecraft has been our eyes on the ground, or rather, in the sky. During its recent flybys, Juno's instruments were working overtime. One of the most impressive feats was the high-resolution recording of magnetic field observations at a staggering 64 Hz. That's 64 measurements every single second. This level of detail allowed scientists to see the tiny, rapid fluctuations in the magnetic field that were previously invisible. It's like moving from a blurry photograph to a high-speed, Ultra HD video of a lightning storm. What did Juno actually find? It found that the magnetic environment is even more unpredictable than we imagined. The data revealed unexpected variations in electrons, suggesting that the way energy is transferred between Io and Jupiter is much more violent than our simulations predicted. We aren't just seeing a steady flow of electricity. We're seeing bursts, surges, and sudden shifts. It turns out the battery doesn't just provide steady power, it occasionally sparks and shorts out in ways that defy our current understanding of plasma physics. One of the most mind-bending discoveries involves a phenomenon called magnetic reconnection. This occurs in the plasma disk at approximately 23 Jupiter radii. Imagine two magnetic field lines that are being pushed together so hard that they actually snap and reconnect, releasing a massive amount of stored energy. It's like a cosmic rubber band snapping. This process is a major driver of the energy in Jupiter's magnetosphere, and it's fueled almost entirely by the chaotic mess Io creates in its wake. It's a beautiful, terrifying cycle of energy release. And let's not forget the surface itself. Juno's observations have identified brand new volcanic eruptions and hotspots on Io that we never knew existed. We've even seen evidence of hot rings, which are highly suggestive of massive lava lakes swirling on the surface. These aren't just small puddles of fire. They are gargantuan oceans of molten rock that are constantly reshaping the moon's crust. Every time a new lava lake forms, it changes the amount of material being pumped into the plasma torus, which in turn changes the entire electrical circuit of the Jupiter system. So, why does this matter to us back on Earth? It matters because Io is a laboratory for the extreme. By studying how this moon interacts with Jupiter, we are learning how planets and moons interact across the entire universe. We are seeing how magnetic fields can shape the evolution of entire solar systems. The impossible physics of Io is teaching us that the universe is much more interconnected and much more electrically active than we ever dared to dream. It's a reminder that even a small moon can have a massive impact on its surroundings. As we look toward the future, the questions only get bigger. Will future missions be able to land on Io and measure this electricity directly? Can we use these findings to predict the behavior of exoplanets orbiting highly magnetic stars? The data from Juno has opened a door, but we have only just begun to walk through it. The mystery of Io's magnetic field isn't just a puzzle to be solved. It's a gateway to understanding the true chaotic nature of the cosmos. There is so much more to discover in the shadow of Jupiter. If you found this deep dive into the chaos of Io fascinating, make sure to hit that subscribe button and ring the bell. We are constantly hunting for the most incredible, impossible stories in science, and you won't want to miss what's coming next. Join the SciNova community as we continue to explore the mysteries of the universe, one planet at a time. Thanks for watching, and keep looking up.